Hello. My name is Xavier from Lys in Luxembourg, and I am presenting you NewtCAM, which is also visible here in the hardware session. So I will be more quick here on the description of the hardware. So it's an underwater camera trap. It means that there is a part that goes into water. The principle is that individuals are freely swimming, and eventually they can enter in the device and move in front of the camera in the middle. It triggers the recording of images and videos, and it uses two types of light, visible light or near-infrared light, so to produce color image or grayscale images, depending on what you are targeting. And it has a ballast, which allows to control that you can film with different material for choice, to control the floating or sinking if you want to target different area microhabitat. Position in water to target different body size. Here are examples of images that are produced in a pond in Luxembourg. So originally we targeted Newt, but at the beginning insect were out, please. let Newt enter. And then we discovered that actually it's interesting also to have insects. So they're also insects, just an example. Yes, it's nice because we have an interaction and so on. That's color images. What is interesting also is that the images are quite standardized in terms of background of light. Here it's visible light. And also in terms of distance to the camera, turbidity of water, even if in turbid water, actually you can still have good quality. And also, yes, the position and distance to camera. So it creates a more homogeneous database for automating afterward the processing. Here, just a screenshot of the app that we developed to control the parameters of the device. This can be shown also later. It's available in GitHub also. And for the data processing, we developed a web app that is currently used for internal use at the moment. It supports the manual annotation and processing of images. So you can crop the area of interest and associate to a species, stage, sex, and whatever behavior. And it creates a database behind that you can export and easily update training classifier or other method. Just a simple representation of observations, graphical representation. Here's for great crescent newt, male and female, and activity pattern at our resolution, just to show that like other automated methods, it's working continuously, so the time series is really higher resolution. Currently, we have 50 units that have been produced with our partner NHBS in the UK. And they have been spread to early users worldwide, targeting different taxa. Yes, we hope that it will be soon available for users, for more users. So we are here to speak about collaboration, potential collaboration. So we are currently producing images, and there's the need to update the reference image. But also the automated solution to process all those images, classifier, or develop morphometrics. But of course, there is also the need to understand the biological meaning of those time series, because it's a different method of observation on the field. So yes, to see what is the change of detection rate by species, stage sex. It's unmarked individuals, so the frequency of detection, what does it mean in terms of density or biomass? Because insects are also biomass to feed newt, so it's interesting to know it and to explore the phenology. NewtCAM should be compared also with standard methods that are used for insects, freshwater insects. And of course, there is room for customization to have something more targeting insects and not as originally Newt, even if it's really quite useful. And also understand the effect of microhabitat in the surrounding of the the device in the water, environmental variables and so on, and light type, because we observed that visible light attracts a lot of insects. So what effect it has on what we observe. Thank you.